All right, we're going to talk about containers, and we'll talk about a couple different types of containers. We'll start with arrays. Arrays are used to group collections of variables all of the same type. So in Java, the array itself is an object. So let me draw a picture here. Okay, this is how we create an array in Java, and the object or the array itself is an object, so we can do things like this. Okay, notice here array.length is actually not a method call. This is a piece of data, a public piece of data that belongs to the array object. So make sure you don't include the parentheses there. I'm not quite sure why they did that, why they made that, why they exposed that piece of data, but they did. And of course, the length is will be the number of elements that are in the array. Okay, so in this case, the loop will iterate 10 times. To declare an array, first we create a reference to the array object. So let me give you another example here. This time let's have an array of characters. Okay, and here we don't specify the number of elements, okay, because this is just creating the reference, but we do want to specify the actual type. So if we were to look at our memory here, all we've done at this point is created this reference called S. Okay, we have not created any characters yet, and we have not created any arrays yet. Okay, the next step is to create room for a couple characters on the heap. What this says is go find room for 4 characters on the heap. Make sure they're all right next to each other. And return the address of the very first one to be stored inside this reference called S. Okay, so now S points to this collection of characters. And then if we wanted to, at this point, we can use the array like we would in, say, C++. If we said S at position 0 is equal to the letter M, for example, or S at position 1 is equal to the letter A, and so on. Okay, so the two examples we've done so far have been arrays of built-in objects, ints and characters. When creating an array of non-built-in types or objects, there's this extra step that we have to go through. Okay, so this time let's create an array of strings that we'll call names. So this is step 1 here. This creates a reference to the array itself. Okay, so there's 4 steps here when we're creating an array of objects. You first create the reference to the array, then you create the array of references, then you loop through that array of references and create actual objects. And only after that point can you then use the array of objects. Okay, so we've got to step 1 here. Again, if this is our memory, okay, at this point we just have this single reference called names. Okay, next we're going to create an array of references to strings. Okay, this is step 2. We're creating the array of reference objects, but at this point we have not created any actual strings. So this thing names right now points to this array of exactly 3 items, but these items are string references. These are not strings. These are pointers. These hold the address of things. Okay, so step 3 says we have to loop through and actually create the objects. So names at position I refers to not a string, but a reference to a string. So what we have to do is set it equal to a new string. Okay, so what this does, this says go find room for a string, put the text mark in there, and we're going to have, this guy's going to point there. And then of course we're doing this 3 times. Okay, so we have this one reference called names that points to this array of 3 references of strings, and each one of these references points to the actual, these are the actual string objects over here. Okay, that's step 3 was to create the actual objects, and then lastly, if we want to use the objects, we have to, then we can kind of go back to our normal notation where we could do something like this. We could say if names at position 0. Okay, so what this is a reference to a string. So we can use our dot notation now to say call a method. Okay, so those are our 4 steps. We created the reference, we created the array of references, we loop through to create the objects, and then we can use the array of objects. Okay, there's also a shorthand notation for creating an array of objects. Okay, so string names and then an empty set of square brackets here. And then I forgot my little curly braces here. We're going to surround this comma-separated list of calls to new with this set of curly braces. And then you could put all of these on the same line or on multiple lines. You can't, however, break up a string in the middle of a line. Okay, so don't forget that closing curly brace there. Okay, so sometimes this is useful if you know you're going to create some hard-coded objects. You could do something like this. Okay, in Java, multi-dimensional arrays are really just arrays of arrays. Okay, so let me draw a picture of that. Okay, so what we're going to build here is this array of 4 arrays. Okay, so here's an array of arrays, and if we're dealing with objects, what we're going to have to do is create these individual objects as well. So it's kind of this is definitely a multi-step process. Okay, so code-wise, what we would do is we would start with this is how we say we want a 2-dimensional array. Okay, here we just specify the first dimension. Right, so this is creating this part of the array. So we need to specify exactly how many elements are going to be in that first dimension. And then we need to loop through so array at position I is going to be one of these references here. Now we need to create the sub-array. Okay. And again, at this point we haven't created any strings yet. We've only created the array of arrays. Okay, the next step is to actually create the string object, so we'll need another for loop. This time we'll look at ARR at position I's length. And now finally we'll start creating some strings. Okay, so again, it's kind of a difficult process here. The fact that we have references, everything's a reference in Java, so creating multi-dimensional arrays is a little bit tricky. But once you get the picture down, I think the code isn't too terrible. Some other things about arrays in Java: when you go outside the bounds of an array, an exception is thrown. And in Java, an uncaught exception will cause the program to stop and give you an error message about where the exception was thrown. So it'll give you the file name, the line number, the exception type. And exceptions are objects, just like any other object. You can ask them to do certain things for you. So for example, if when you go outside the bounds of an array, you get this type of exception called an array index out of bounds exception, which you can go look up in JavaDoc. And there's a method of all exceptions include this method called a print stack trace. And this prints your call stack so you can see exactly how you got to the point where the exception was thrown. That's very useful. Okay, Java also has built-in containers very similar to the ones we learned about in data structures. And you will almost always want to prefer these built-in containers over plain old arrays. Okay, however, occasionally you'll still need to use an array for one reason or another. So that's why I talked about them before. You are almost always going to want to use these built-in containers. So the built-in containers, they can grow and shrink at runtime, and most containers are in this package called java.util. So that's the utility package. There's a lot of stuff there. Okay, so let's talk about our first container. Is called an array list. An array list is very much like a C++ vector. Okay, so I could do something like this. So I might create an array list of strings called addresses. Okay, every time you create a new object on the heap, you have to include the set of parentheses here to indicate you're calling the constructor for that object. This is a little bit different in C++. In C++, you don't, if you're calling the default empty constructor, you don't include those parentheses. In Java, you must include those parentheses. So this creates an array of strings called ADDR for addresses, and the if you leave the constructor empty, I think you start out with a 10 element array list. However, if you put a number in there like 20, okay, there is a constructor that takes a default size or an initial capacity. Okay, so this is a little bit hard to read, but this says create an array list of 20 elements. Okay, and of course the array list can grow and shrink just like a C++ vector. So when you pass in a value to the constructor, it's just an initial value. It's not set in stone. Let's say we had maybe this student type. So I'm going to, again, create a new student on the heap. Notice the parentheses, those are required. Now I'm going to have an array list of students. Again, because I use the default empty constructor here, the initial capacity will be 10. So what I'm going to do is 10 times I'm going to add an element to this container. So the way you do that is you give the name of the container a dot, and then you call the add method. Okay, and what's really important to remember here is array lists do not hold objects. They hold references to objects. Okay, so what I'm really doing here is storing 10 pointers that all point to the same student object that I declared up above. Okay, in a C++ vector, what happens when you add or push back is it makes a copy of the data, and the copy sits on the vector. Okay, array lists are different. They always hold references or pointers. Okay, once we have these student references on the array list, we could retrieve them by doing something like this with the get call. So get takes an integer. Okay, so students.get at position 0 says return the reference at position 0. We could now call, for example, the equals method to see is it equal to some other object. Okay, so an array list is like a C++ vector in that it grows dynamically, it grows automatically. You just keep calling add. Add is equivalent to pushback. Array lists are templated, and templates are actually a relatively recent update to the Java language. For many years there were no templates. The good thing about the array list is it's random access, meaning it takes the exact same amount of time to grab the first element as it does the, say, 100th. This is a little bit different than, remember, our linked list class, where you had to traverse 100 times to get to the 100th element. An array list has random access. Now, an array list is different from a C++ vector, like I mentioned before. The array list holds references to objects, not the copies of actual objects like we get in C++. Okay, so I suggest you look at the Java doc for the ArrayList class right now, and what you'll find in there is there's some remove methods. So you can call remove and pass in an integer that'll go to that position in the array list and remove that item. Of course, everything will have to be shifted over to the left if you are removing from the middle. So that's not the most efficient operation in the world. So if you know you're going to do a lot of removing, then perhaps you should use a different type of container like a linked list. There's a remove that takes an object. So if you know an object is already being stored in the array list, you can call remove and pass a reference to that object, and the array list will go find that object and remove it. There's a clear method that will clear out all the elements. There's a contains method which will return a true or false. You pass in another object, and the array list will tell you yes or no that object is in the array list. There's a toArray method, which if you do for some reason happen to need a plain old Java array, the array list can turn itself into an array. There are a couple different ways to iterate through an array list. Okay, and we've already seen a couple ways, or at least one way already, with the plain old for loop. Okay, so let's say I had an array list of, I don't know, strings called myList. creates an empty array list. Now let's pretend I added a bunch of things to this list. Okay, and we want to iterate through this list. Well, we already saw the for syntax. Okay, now notice this is an array list, not a plain old array. There is a length method, and it's actually a method this time. Remember the array, it was this public piece of data that was exposed. Okay, there are no square bracket operators in Java. If you want to pull something off a container, you call the get method, and you pass in an index. Okay, that's one way to iterate through this collection. Another way is to use this thing called an iterator. Okay, so here we're creating this object called iter, and the list itself will give you an iterator. There's a method. Okay, so mylist.iterator, and then you could say while iter.hasNext. That will return true as long as there are more items to iterate through. So then we could create a string reference called name, and if we say iter.next, okay, that will return a reference to the next string that's on this collection, and then we could print the name there. And then lastly, we have this the syntax called for each in. So this is similar to the two approaches above, kind of combining the best parts of both. Okay, so what this says is basically for each string, which we're going to call name is going to refer to each one of the strings, in, that's what the colon here means, the collection called mylist, okay, we'll be able to access each string using name. Like this. Okay, and this is pretty nice because if you're like me, you've written this for int I equals 0 while I is less than, you've written that thousands and thousands of times in your life. Well, this reads a little bit better. This just says for string name in mylist, and then you refer name refers to each one of the elements in that collection, each iteration through the loop. Okay, so the loop will stop once we've gone through all the elements. Okay, we've talked a little bit about the array list. There's actually a collections interface. We'll talk more about interfaces later, but there's this collections interface that make all containers kind of look and feel similar. So all of the lists kind of look and feel the same. We've only looked at the array list, but there's also something called a linked list, which is, again, it's a generic container that you can iterate through, but it has links forward and backward instead of being array-based. There's a container type called a vector. It's kind of an older data type from the very early days of Java. We don't use vectors anymore. We use arrayless and linkless, but you might see vector code here and there. There are these things called sets. So a set is a collection that has no repeats. So there's this thing called a hash set and a linked hash set and a tree set. There's a data type called a map. These are key value pairs, very much like our hash tables that we created in data structures. So here duplicates are allowed. With a set there's no duplicates allowed, but a map does permit duplicates. And again, there's different implementations of a map. There's a tree map and a hash map. And how they're actually implemented, I suppose you could go look up the actual implementation. But the hash map, I'm guessing, has some kind of chained hashing where we have a list of linked lists like we did in our hash table from data structures.